So in this lecture we are going to talk about the half angle identities. Let's quickly review what we have already done in terms of double angle identities. These are just going to be sisters of those. So we had cosine of 2 theta, we had 2 versions for this, or 3 versions for this. We had sine of 2 theta, was 2 sine of theta, cosine theta. And we had tangent of 2 theta, was 2 tangent of theta over 1 minus tangent square of theta. Now half angle identities kind of maneuvered or extracted out of this one, and in some indirect way out of that. Let's see how does that go. Take this equation, rearrange it. So I'm taking cosine of 2 theta is equal to 2 cosine square of theta minus 1. Move the 1 to this side, so it becomes it's negative. Add the 1 to both sides. Divide both sides by 2. Now the way this looks is that the angle here is half of the angle over there. So this identity is really what you had here to begin with. You just rearrange it. Sometimes to make it kind of explicit that one of these is half of the other one, they might write it like this. They might say 1 plus cosine of x. If I replace 2 theta by x, what should I replace theta with? Okay, now this forces us to think about half of somebody. So this is half of the angle x. Its square of its cosine is given by this formula. Sometimes people want to see the actual quantity, x cosine of x over 2. So what should I do to get rid of this 2? I have to take square root. Is that right? So I go ahead and take square root. 1 plus cosine of x over 2, except that when you take square root, it could have been coming out with positive or negative square root. Either of them might have come in. So this is one of our formulas. We might have started the same thing with the other one. That is, I might say, well, look, I could have said cosine of 2 theta is equal to 1 minus 2 sine square of theta. Is that right? I rearrange this in the sense that I take cosine and bring it to the right, take the sine, take it to the left. Remember, when you cross an equation and you are added to one side, then the opposite side will be subtracted, and vice versa. So this minus 2 sine squared, when it comes to this side, becomes plus 2 sine squared of theta. Or as you say in high school, add 2 sine squared to both sides. And subtract cosine of theta, 2 theta from both sides. Okay, so this is just a rearrangement of that. Next, I got rid of 2. Next, I get rid of the square. Again, when you take square root, you have plus or minus. If you want to force people to think that this is really half of that, one way to do that is, again, use the same trick. So I'll say sine of, if instead of theta I use x over 2, then 2 theta is just x, and the title of this section becomes more meaningful. We said our title is half angle identities, so this is half of that. Notice in both of these things, we have the same function on the right hand side is cosine, so it's more cosine is more prominent here. What else can we do? Well, before we go any further, how do we choose plus or minuses? It all depends what quadrant you happen to be in. You have to decide what quadrant your x over 2 is. Based on that, decide what flavor your function has, and based on that, choose your plus or minuses. Now, the way we have written this, it doesn't mean that plus goes with plus or minus goes with minus. Any of these could go with any of those, and vice versa. So there is no ordering involved here. Next thing we want to do is, what is tangent of x over 2? Fortunately or unfortunately, there are actually three ways of looking at it. One of it is straightforward. One of it is to say tangent is the ratio of sine to cosine. Now, since we said these plus or minuses don't correlate with each other, you still have a plus or minus. Take a ratio of this to that. What's going to cancel? 2's are going to cancel, and we are just left with this. Divided by that, this is one version. So this is formula number 3 for half angle formula. Now, there are two other formats for this which are kind of interesting that avoid the radical altogether. Let's talk about that. Here, as an exercise, I might ask you to show that tangent of x over 2 is also equal to sine of x over 1 plus cosine of x. Okay, we think about this thing, see, well, how can I show such a thing? Tangent is a ratio of sine to cosine, yeah, sine of x over 2 over cosine of x over 2. So somehow I have to convert these guys back to their half angle formats. So let's remember, what was sine of x? Let's see if I... Okay. We want to force things for the half angle to come up. Look at this identity and tell me, how can you rewrite it? So on the left, I have sine of x, and on the right, well, that's for you to find out. What's going to be on the right? If I have sine of x, 2 sine of what? X over 2 cosine x. So if I take all of this, replace it by x, then I have to take theta and replace it by what? X over 2, and same story here. So that identity, exact same thing is being used here, just perhaps it's not as fresh in your mind as elsewhere. Sine of x over 2 times cosine of x over 2. So if you want to talk about this as a half angle or double angle identity, either way, that's fine with me. So far you get the form of it right. How about denominator? Let's say if that showed up anywhere in our progression. 1 plus cosine of 2 theta is 2 cosine square of theta. What is 1 plus cosine of x?
2 cosine squared over 2.
Yes, very good. So we have 1 plus cosine of x is equal to 2 cosine square of x over 2. So if this one we have established from prior identity, this one established from prior identity. So I can take them and divide them, see what happens. Why I divide them? Because somebody is telling me, look, I have this, can you show me where it comes from? I say, okay. Sine of x, I replace it by that 2 sine of x over 2 cosine of x over 2. Denominator is 2 cosine square of x over 2. Now can you tell me what cancels out and what stays? This 2 and this 2 cancel out. Is that right? What else cancels out? This cosine square, cosine of x over 2, there are 2 of them in the denominator. One of them is going to be taken out. So we are left with sine of x over 2 over cosine of x over 2, which is what? Sine over cosine is tangent of x over 2. So rather roundabout way, that expression turns out to be like that. So let's make a note of it, that tangent of x over 2 has another format in terms of double angles. Sine of x over 1 plus cosine of x. What is great thing about that compared to this? You don't suffer through the square root. You don't suffer through figuring out does it have to be plus here or minus here. It automatically does everything. So it is a great identity. And if that were not enough, there is another way of handling tangent of x over 2. There are really zillions of these things, so after a while you kind of get a feeling for 1 minus cosine of x over sine of x, and I leave the proof of that to you. You just followed similar kind of reasoning as we did here. So here is in their full glory. These are half angle formulas. And once again, I have no choice but impose this on you. This is you have to memorize them once in your life at least to be able to use them later on. So they could show up on the test on Monday. Now let's go ahead and answer questions, and as well as doing some exercises.
When you say know them, just know them or know how to apply them? When you ask them to apply them.
Well, I mean, there are degrees of knowing them. And so first you want to know the identities. We need to memorize the form of identities as they are. Then in the problems that come up, like if you go ahead and do a sum of these things, problem 27 through 34, you see applications of it. That is, you need to know what is happening here to be able to simplify those. Maybe I do a couple of them, and that's as good as of a practice as anything, so that I am answering also your question. So for example, let's problem 27. It says simplify 2 cosine square of x over 2 minus 1. Here's a way of helping you. You can always, you have all these formulas in your head. You might be wondering which one of them is correct, especially in the exam, all the nervous conditions and such. You can always test them instead of fighting with yourself. Is it this formula? Is it that formula? You can pick some particular angles and say which one of your guesses actually correct with respect to that example. If you check 3, 4 and it checks out in all of them, then you have more confidence in the guess you have. But you have to have a guess for the right hand side. What is your guess here? Which one of our formulas does it resemble? What was this? You see, two cosine square of something minus 1 has to remind you of cosine of a double of that guy. So what does that say here? This is cosine of 2x over 2, which is cosine of x. So first you have to arrive at such a guess. If in your mind you are wondering, was it cosine, was it sine, was it tangent? Well, you are likely to say tangent, but if you have a guess here, then you can go check it. Your calculator, your memory, either comfortable angles or just any angle, see if matches. But then of course you have to be comfortable with that checking step itself, using your calculator from memory, 30 degrees, 60 degrees and such. So you have a fallback position. So examples here says simplify. Again, that dreaded word, simplify. They say babies don't come with user manuals, and actually mathematics doesn't come with a user manual either. It's like, you know, do whatever you can do. So 28. Cosine x, yeah, simplify. We simplified it. You know, everybody agrees once it's done that this is simpler than that. But the issue is, you know, beforehand, what do you mean? How did you simplify? So let's just by practice. Cosine to power of 4 of x minus sine to power of 4 of x. We had seen this before. We had stopped early. Now we go one more step. What did we do? Cosine square of x minus sine square of x times cosine square of x plus sine square of x. So this is the identity for difference of squares. Now, okay, that much we would have done in algebra, but in trig we say we have other things to say. What is this? 1. And today we learned something new. What is that? Cosine square of x minus sine square of x. How does that become 0? That is this side. Cosine 2x. So it boils down to cosine of 2x. So that's what we expect to see on Monday. That, okay, I see that this is a simplified form of that thing. And here are the steps. And I remember this because in the first half we just did that. Cosine square of x minus sine square of x is cosine of 2x. What else? Let's do one more. 29 sine x minus cosine x squared plus sine of 2x. Okay, you suggest to me what to do next. Sine x what? Well, we look at this. No. This is asking you to square the difference of two items. If you add a minus b squared, what is that going to be? A squared plus b squared minus 2ab. Is that right? So let's do that here. Square of the first item. Square of the second item. Minus twice the first and second. And then we add the sine of 2x trailing the whole thing. Now let's look at this thing, see if we can detect any simplification. What do you notice?
First part is 1.
This is 1. What else?
The other two cancel.
Yeah, this is what we learned today. Sine of 2x is 2 sine cosine, and this minus that plus. So that whole thing magically just boils down to 1. Problem 31. 2 minus secant square of x over secant square of x. Okay, just about everything we said today was on primary functions, sine, cosine, tangent. Secondary functions, secant, cosecant, cotangent. If you come across them, one of the good bets is to convert everything back to sine and cosine, clean it up, and then at the end, if you want to go back to those secondary functions, that's fine. But since we didn't see any secant today, staring at this is not going to help us. We say, okay, let's first be smart and go back to primary function. What is secant? This is one of those reciprocal functions, you remember? So this is 1 over cosine square of x. And same in the denominator. Now, your expertise in college algebra comes in. How do you clean up a complex fraction like this? Fraction in a fraction. Multiply by? Very good. You look at all the denominators, you find out the least common denominator of everybody and multiply by that. That's the fastest way of cleaning them up. Or perhaps just take common denominator and flip the fraction and multiply. Just about every student can do it his or her own way. Okay, let's help me out with the numerator. When I multiply this parenthesis with cosine square, what's the first entry that's going to show up? 2 cosine square of x. Minus 1, very good. So that cosine cancelled out. In denominator, what am I left with? 1. Now 2 cosine square minus 1, that should remind you of the identity. In these problems, it's a pattern recognition that is important. That you look at that, and some light has to go off in your mind. I've seen the sky before. 2 cosine square minus 1, I have seen this guy before. It's cosine of 2x. So admittedly, this is cleaner expression than this one is. Let's do one more. 1 plus sine of 2x plus cosine of 2x over 1 plus sine of 2x minus cosine of 2x. Let me admit that I don't know what to do. So you tell me what to do. What portion of this reminds us of stuff we have seen? Factor out something. We cannot factor in much of anything. Let's try the following. What if I kind of suggest we go this route, see if it takes us anywhere. If not, we come back to square 0 and try again. So I just wrote the cosine near 1 because of what? Because we had 1 plus cosine, I have an expression for it. 1 minus cosine, I have an expression for it. Is that right? 1 plus cosine, 1 minus sine. So let me see if you can help me out here. So did that stay in your mind? What was 1 plus cosine? That was 2 cosine square of x. Is that right? How about denominator?
2 sine square x.
Do you remember the identity for sine of 2x? Let's see if that helps us any. Sine of 2x, shouldn't have forgotten by now. Sine of 2x was 2 sine of x times, say it before I get there, sine of 2x, 2 sine x cosine x. 2 sine x cosine x. So I think Peggy could see 3 steps down the chess game, see what's going to happen next. So we do our factorization now. Is that right? That's what you wanted to do. So what do we factor here? From numerator, what can you factor? 2 cosine x. Is that right? Help me out factor this thing. What is left? What's left? No, let's do the same thing in denominator. What can I factor?
2 sine.
What is in the parentheses?
Sine x cosine x.
Now what happens? Everybody sees these are the same. Is that right? Just written in opposite order. So I'm left with cosine x over sine x. What is that? So this little guy was hidden under this big look. So let me leave a few of these things for you guys. Let me answer some of the questions you raised, and we need to do more exercises, so perhaps you collect all of your questions, and tomorrow we allocate a substantial amount of time to answering any questions you might have. But you need to have those problems tried, so you have some idea about it. You have looked around, you have tried something, then my answer is going to be helpful to you. Otherwise, it's not going to be all that helpful. Next section, section 2.3 is just more of the same plus more exercises. So be prepared. We still have stuff to handle. And let me remind you again, every single one of these identities that we are seeing, those major identities, every single one of them do show up in practice somewhere. It's just that they are scattered all over the place. Your feeling right now is like you have walked into Home Depot and somebody is explaining every single tool that is there. And so okay, what do I do with these things? Well, 2 years from now you are going to need this drill, and 3 years from now you are going to need that saw, and so on. So introduction to Home Depot's tool section is not going to be all that fun if you are not doing something with it. But somehow that's the trick course anyway. That's all of it is accumulated and presented in front of you. You try them out, and then you go do something with it later on. They are all of use. There is not a single one of these. There are, I think once I counted, there are 72 formulas. And there isn't any redundancy in any of them. It's just, okay. Yeah, I mean, it adds up. It goes on and on and on. We have sum and difference formulas coming up in reverse in the next section. And when you put it all,
Will 2.3 be on the exam?
no, I don't think that's going to be pushing it. So 2.3 going to be on the next one.
1.5 to 2.2 then.
Yes, that's plenty. So we have a challenging section on the graphing and a challenge to deal with all these formulas. So please don't postpone everything to the Sunday. That's not going to work. So make sure you do quite a bit, a few of each of these sections for tomorrow. Bring me your questions, and then I try to allocate at least half of the class time to your questions. So let me see if I can quickly go through. I didn't expect that. Don't even recognize that number. Let's see. Sorry for that. What were we going to do? Answer your questions. First one was let x to be secant of theta in radical x squared minus 25. Find sine of theta and cosine of theta. Two ways to approach this. One is by a picture, and the other one is by the formulas. So we have an expression here, and we are also given that all of our angles are in the first quadrant. Well, let's go use secant. So this expression, let's call it expression E. I go ahead and say my x is, this is 5 secant. I didn't read it correctly, so okay. And let me, so well, I can, I guess, squeeze this thing here, 5 secant. Replace this. This is 5 secant square of theta, 5 secant of theta squared minus 25. So that's going to be radical 25 secant square of theta minus 25. I can factor the 25. So 25 comes out of radical. I have so far secant square of theta minus 1. The question is, do I recognize what this thing is? Secant square of theta, let's see if you remember, these are trig identities from very beginning. Let's just repeat to ourselves what it was. Sine squared plus cosine squared equal to 1 was our main identity. How can I create a secant out of it? If I divide everything by cosine square, so I'll have tangent square of theta plus 1 is equal to 1 over secant square, which is 1 over cosine square, which is secant square of theta. Now, secant square minus 1, either I go through the reasoning like this, or I remember from the list of the identities, and as I said, there's just plenty of them. I realize that this is same as tangent. So what are we supposed to do? Find sine and cosine. It says find sine. Let me restart this thing. So if it had asked me to get tangent I found tangent. Tangent of theta is 1/5 of that expression.
Can we find sine, cosine?
Sine and cosine. Well, maybe I went through unnecessarily long expression here. So tangent of theta would have been let me restart this problem. So we had x is equal to 5 secant of theta, and the other expression was radical x squared minus 25. Let me draw a picture so that the picture perhaps will guide us to the correct path quickly and less convoluted. How would you label your sides of this triangle so it matches these things? So suppose this is
Looks a lot like the Pythagorean theorem. Can we use that?
what would be this one?
X squared.
This is for now. This is a hypotenuse. What connection do you know between these three quantities? You know cosine of theta is going to be ratio of adjacent to the hypotenuse, or if I want to use some of the functions that I see in front of me, what would be secant of theta? H over 5. So that tells me what is h. 5 secant of theta. So here is our x. X is the length of the hypotenuse in this problem. It is 5 secant of theta. So if this is 5, this is theta, hypotenuse is our x, 5 secant of theta. Who is going to be this leg? Again, remember this is x, this is 5. What is our vertical leg? Square root of, just use the Pythagorean theorem. This is x, this is 5, so x squared minus 25. Now if we label these things correctly, anything the problem is asking us, we can get it easily. Such as sine theta. Just read it out from the definition. Sine is a ratio of opposite to hypotenuse. Just use the expression involving x to get your answer. Who is my opposite? Who is my hypotenuse? Yeah, we don't want to mix and match. We want all thetas one side, all x's the other side. So it's just x. Because x were substituted by 5 secant theta. So this way, things are perhaps less of a guesswork. If you want cosine theta, what is cosine theta in terms of x? 5 over x. This you could have gotten from here immediately. Is that right? Perhaps that's what the book wanted you to do. So, secant of theta is 1 over cosine theta. So if you want cosine theta, it's going to be 5 over x. Everybody sees that? If you exchange x and cosine, you get that. If you start with this, you have an alternate way of getting your sine of theta. But before we go there, let me add this one also. Tangent of theta, we did in the previous word, is a ratio of opposite to adjacent, so you have that one. So this was one way of going about this, and you might come across different solution either in the text or in the videos that come with the text. So we are over time. Okay. Please bring up the questions I didn't answer today. Bring it up tomorrow, and we'll try it again.